So we're in section 2.4, and we're going to talk about deductive reasoning. The first thing I want to do is contrast a little bit inductive and deductive reasoning. So there's two basic types of reasoning that we're going to use. Inductive. Inductive reasoning is when we start with observation or experiment. And then we make conjectures. And by conjecture, all we mean by conjecture is say what we think is true. So I might look outside and say, oh, it's cloudy outside. I think it's cold. That would be inductive reasoning, because based on my observation, I say what I think is true. So most of science uses inductive reasoning. We do experiments, we do observations, and then we say what we think is true, and then we test that. Well, if this is true, then this other thing must be true. Or if this is how this works, then we try to figure other things out. But usually we start with an observation or experiment. Deductive reasoning. Deductive reasoning is more like what we usually do in math, more like what happens, well, I guess a legal case, you use a little bit of combination. But if you're arguing something as a lawyer, often you'll use deductive reasoning. You start with what you know is true. So you start with facts, and then you use logic to figure out what else has to be true. So deductive reasoning, we start with some facts, and then we use logical arguments, usually conditional statements, put those together to figure out what else has to be true if we start with these facts. So today we're going to talk about two main tools using deductive reasoning. All right, so we okay with the difference? All right, our first main tool is the law of detachment. Law of detachment lets us draw a conclusion from a true conditional. So what we're saying is we have if P, then Q. And we know this is true. So we have a true conditional. We know P is true. So Q must be true. So I'm going to say if we know P is true, Q must be true. So it lets us draw a conclusion. So for example, let's go back to the conditional that we used a lot the other day. If you're a math teacher, then you know algebra. we decided the other day that this was a true conditional statement. And now I'm going to say Mr. Evans is a math teacher. So if we know that this is a true conditional, we have a specific example of this first part. So what can we conclude? Mr. Evans knows algebra. So we draw a conclusion from a specific example of the first part of the conditional statement. We know the conditional statement's true. We draw a conclusion from that. So let's look at another example, and I want to point out where we have to be a little bit careful. If you get an A on your test, then you get candy. So for the first example, I'm going to say you get 92%. So what can we conclude? What else do we know? You get a 92% on your test. If this is true, we're saying this is true. What else can we figure out? You get candy. We have a specific example. You got 92%. That means you get candy. What if you start out by saying that you have candy? Can we figure out, does that tell us that you got an A on your test? Is getting an A on your test the only possible way in the universe you could get candy? No. So we need the first part. We need to know an example of the first part of the conditional statement, the P part. We can't say, I'll say we can't say for sure. You got an A. There are other ways you might be able to get candy. Whoever told you that if you got an A you'd get candy might have just felt bad when you got your test back and given you candy anyway. That doesn't make the first part not true. It just means that getting an A is not the only possible way in the universe that you could get candy. So that's where you have to be careful. To use the law of detachment, the first part of your conditional statement, the P part, has to be true. All right, questions there? Yes.
What would this, like, you get a 92%, like, what would that,
That's just something that you know. That's a fact that you know. You get a 92%. It doesn't have a specific name though.
like, on the test, it said, like, hypothesis.
That doesn't have any special. That's just a fact. All right, let's talk about the second way that we're going to use conditional statements, and that is the law of syllogism. The law of syllogism lets us link true conditional statements. And I'm going to say we link them back to front. So law of syllogism lets us put together several conditional statements. So I'm going to say if P then Q is true, and Q, if Q then R is true, so we can put these together back to front. We have a Q at the back of this one. We have a Q at the front of this one. We can say if P then R is true. So I'm linking together the back of this one with the front of this one, and then I'm putting them together and just going straight from there to there. So I link them together back to front. And then the law of syllogism just lets me bypass all the middle stuff and get right from the beginning to the end. So let's look at an example of this using our math teacher example. If you are a math teacher, then you know algebra. If you know algebra, then you know how to factor. So what we want to do is link these together back to front, like so. So I have you know algebra here and you know algebra here at the back of the first one, the front of the second one. So we're going to link those two together and just bypass the middle stuff. So we're going to go straight from the beginning. If you are a math teacher, then you know how to factor. So we're going to go straight from there to there. I'll just write it that way. Then you can factor. And we could put several other pieces in that chain and link two or more conditional statements. I could say if you're a math teacher, you know algebra, then you know how to factor. If you know how to factor, then you can solve quadratic equations. And you can put all three of those together and say if you're a math teacher, then you can solve quadratic equations. You can keep going and put a bunch of them together. All right, let's look at a couple of examples, a couple of other examples of using using the law of syllogism. So for this one, I'm going to ask, what can we conclude? If a number is divisible by 12, then it is divisible by 6. If a number is divisible by 6, then it is divisible by 3. So what can we conclude by putting these two together? Well, can we link them back to front? We have divisible by 6 at the back of that one, and we have divisible by 6 at the front of that one. So we can link these two back to front. So we want to start just with the first part here. If a number is divisible by 12, and we're going to bypass all the middle stuff, then it is divisible by 3. So we're going to go straight from here to there. All right, questions? Questions on that one? All right, same thing here. What can we conclude? What if I said if a shape is a square, then it has 4 sides. And then I said if a shape is a rectangle, then it has 4 sides. Can I link those two together? So remember, we want to link them back to front. So here's the back of the first one. It has 4 sides. But the front of this one is the shape as a rectangle. I need the same thing at the back of this one and the front of that one. So we can't link them together. So I'm going to say no conclusion. So we can't link them. No conclusion. All that we know is that both a square and a rectangle have 4 sides. But we can't put those two together and make one conclusion out of the two things together. All right, questions? Questions on that example? Okay, the last thing for today is using law of syllogism and law of detachment together. So I'm going to say using both. So usually this is how we're going to apply these things. We're going to link together some conditional statements and then make a conclusion from everything that we've put together. So I'm going to say, we'll talk about this just by doing an example. If you live in Denver, then you live in Colorado. If you live in Colorado, you live in the West. And I'm going to say Joe lives in Denver. And we want to know, what can we conclude? What can we figure out? Well, we link these two conditional statements together. We can link them together back to front, right? This one says you live in Colorado. The front of that one says you live in Colorado. So we can put those together to say if you live in Denver, you live in the West. Well, Joe lives in Denver. There's a specific example of the first part there. So what do we conclude? Joe lives in the West. So often we'll link several conditional statements together and then make a conclusion from what we get after we put them all together. And that's where we're using the law of syllogism, law of detachment together. Use a law of syllogism to link together our conditional statements. We use a law of detachment to make a conclusion. All right, questions? All right, so big picture, our main idea. Syllogism links conditionals. Detachment, we draw a conclusion. About a specific example of the first part of a conditional statement. There is, I want to talk really quickly, there's an extra credit opportunity for Chapter 2. It is available on my website. It's in the geometry handouts section in the homework, or the worksheets folder. It's a syllogism project, and I have a couple of examples here that I wanted to share that you can have a little bit of fun with this. So what you're doing is you're linking together several conditional statements. So this person links some conditional statements together to conclude that if I like candy corn, then I do ritual sacrifices. So it's kind of interesting. Another one, the syllogism that they came up with was if they drop a pencil, then they'll go to jail. Another one said if it ends up being that if you go to a sleepover, then you will die old, sad, and alone. Another one concluded if you do your homework, then you will contract Ebola and die. So I thought that one was some of these the truth of some of the conditional statements is a little iffy. So all of these were good. Nice pictures on them. Some music there. So if you're interested in that, you can look on my website for a little bit of extra credit. That's due on Friday if you do that. Let me put the homework up here. Okay, there's that.